All right, good morning everybody. I hope you're all doing okay. Welcome back to Comp 3350 Software Engineering 1. Today we are going to be spending some time continuing to look at software development methodologies, and we're also going to start spending some time working on your projects today. So in today's class, my goal is for us to get through building some non-technical planning artifacts so that we have a better sense of what the project is that we're going to be working on. Before I get into that, though, I've agreed to let Wix, Dev Club, and CSSA tell you a little bit about themselves and what they do and what they are and what they can offer for you as students. So I'm going to hand off to Mia, Jillian, and Mosen.
Hello everyone, can you hear me? Okay. Hello everyone, my name is Jillian, this is Mia, and this is Mosen. We are representatives of Wix, CSSA, and Dev Club student groups. Wix stands for Women in Computer Science. We were established about 3 years ago, and our group welcomes students of all genders. Our goal is to build a strong community between all genders in STEM and encourage diversity in the field of computer science. We do outreach events with elementary and junior high schools to help them learn about programming and computer science. Throughout their school term, we also hold workshops and panels on topics such as machine learning, game development, and the co-op program. Our group includes women mentors from the industry, and each term we host events introducing these mentors to students in hopes of helping people network and build connections. We'll run a university mentorship program as well, partnering first and second year students with upper year students. Well, we'll also partner up with the executives of CSSA and Dev Club to host hack days and cram days. We recently have been working with Winnipeg tech companies like Bold, IQ Metrics, Ubisoft, and Amazon to build a stronger community for women in technology. Our goal in Wix is to promote gender diversity, make computer science less intimidating, and create a space for women to connect with other women in computer science. That being said, anyone is welcome to join and help out. We have a Discord channel which you could actively communicate with all members in our community. You can also check us out on our website or Instagram. For this term, we have quite a few events planned already. Our first term meeting for this term will be on January 26th at 6:30 p.m. There will be a registration form posted on Discord and Instagram. We would love to have you. And now for CSSA.
Hi. Let me grab this. Hi, everyone. I'm Mia. I'm here representing the Computer Science Students Association, or CSSA. So me and the other execs on that council are a team of elected individuals that represent the computer science student body. So I've been going around saying, like, if you're in computer science, whether you want to be or not, you are part of the CSSA already. There's a lot of benefits you can get from getting involved in the community, and we're here to help you along with that and support you in your degree. Make sure your voices are heard in the wider U of M community. So we're back in person now, so our CSSA lounge is operational again. That is on the 5th floor of this building. It's at E1 586. So it's a little bit out of the way. If you scan this QR code, that will take you to a link tree. One of the links on that link tree is a video tutorial on how to actually find the lounge, because it's actually like tucked away. It's very hidden, very secretive. We also have a Discord server that we co-moderate with the Wix and Dev Club execs. The sign-up form for that Discord is also on the link tree. We have a separate Google form to sign up so we can keep track of all the members. So that server has channels for each class, including this one. It's a really good place to talk to your classmates more and maybe ask for help with some of the topics or what's happening in lecture and stuff like that. So one of the core beliefs of the CSSA is that building a thriving community is one of the best ways to support students. So we also host a lot of social events throughout the term, like mixers or movie nights. Coming right up, starting on January 27th and going through the weekend till the 29th, we're actually going to be holding our 4th annual CSSA Game Jam. So that's open to all U of M students and all skill levels too. There'll be some more promotional posters and stuff around campus. We'll also be promoting it and advertising it more on the Discord server and on our Instagram if that sounds like something you'd be interested in taking part in. So again, that's how you can keep up to date with us. We hope to see you soon online or in person. Now I'll hand it over to Mohsen.
Hey everyone, I'm Mohsen. I'm a representative for Dev Club. Our club is for any student interested in software development in general and computer science. You don't have to be in computer science or in the science faculty to join. If you want to learn and meet new people, you're welcome with us. We regularly run workshops, coding competitions, and other events throughout the year. We've had workshops about Chrome extensions, generative art, and even a picnic in the past. And we're going to be holding a hackathon in February where you will work on a project for 12 hours in a group or alone if you would want to, and present it to big local tech companies. During our past hackathon in 2019, which was in person too, we had over 200 students coming, and they developed amazing projects like an AI that could censor faces, a stock prediction application, and an Arduino-based survival game, and many more. And we're going to be hosting similar events in the future, so stay tuned. And we're in the same Discord server as Wix and CSSA, so keeping up with us is going to be easy. And yeah, thank you, and come by soon.
Thanks, everyone.
Thanks so much.
Oh, Mia, can I share a link to these slides on my course webpage? Okay, so I'll put a link to the slides up on the course webpage so you have access to all of the contact information for all of the clubs at the same time, okay? So I'll post this up there. Thanks, guys. So let's get started today. The things that I want us to accomplish today are I want to be able to finish taking a look at a couple of different software development methodologies, a couple of different approaches to how we can go about building software together as a team for people. I want to spend some time finishing up with waterfall. So this traditional, this is the way it used to be done. And in reality, the way it is still done sometimes. Waterfall as a process, just because it's old doesn't mean it's bad. It may be inappropriate for certain things, but it's still around. It's still something that happens. I want us to take a look at comparing waterfall, the way we go about developing software in this methodology, to more modern agile approaches. So how do we go about doing that with modern methodologies? Agile itself, we'll see this in a second, is kind of more of an idea than it is an actual methodology. And so we're going to be looking at an actual process that we're going to be doing that kind of fits under this umbrella of what Agile is. And then I want us to spend a little bit of time looking at some non-technical planning artifacts. And I want you to start building non-technical planning artifacts for the project that you're going to be working on throughout the term. So, really quick reminder about what this is. I know it's been like 2 days. You probably remember a lot of this, but I don't think it's going to hurt to spend a quick moment thinking about what this is. Our waterfall model is this idea of we're building requirements at the very beginning. We have a client. The client that we have wants a piece of software to accomplish some task that they have. We're going to go and work with that client to build all of the documentation, all of the planning stuff, everything that they need for this software to be considered a success. We need to figure out what all of that stuff is and produce this documentation, product requirements document. After we get all of those requirements, we go through this design phase of deciding and making conscious decisions about what it is that we're building. So given the requirements, what are we building and how are we actually going to go about building that? Then we implement it. We sit down and we write code. We pass it off to verification, make sure that this software does what it's supposed to do based on the input that was given to us from our client. And then we begin to maintain it. So once we've delivered it to our client, it meets all of this criteria, we give it to our client, they eventually find some bugs, and we have to maintain it. We have to add stuff to it. We have to make changes to it. As we're going through this flow, as we're going through this process, each of these phases are done by different teams. So we had our requirements gathering team here. They gathered the requirements from client A. Once they produced that document, that requirements document, they passed that off to the architecture team. The architecture team started architecting and designing that application. Our requirements gathering team moves on to a new client and starts working on something else. And we keep passing this down the workflow, and each team continues to work independently of all of the other teams. As we went through this, we pass things off from one team to the next. Our client may be involved in different parts of this. They may be involved in software architecture, but the reality is our client doesn't really know that much about software architecture. Our client might be involved in implementation, but the reality is if they knew how to implement code, they wouldn't be asking us to do it. They may definitely be involved in testing and verification. They should know how to use the software that you're building for them to make sure that it actually does what it says it's going to do. They're probably not going to be involved in maintenance. The waterfall model is, as it's delivered, as it's done most of the time, is just a straight through fall down of the software development lifecycle. So it's just taking those phases from the software development lifecycle and applying them iteratively, one at a time. This is one of the activities that I gave you last time, and I'm just going to give you like 1 minute to talk about this and remind yourselves with your team what it was that you came up with. What limitations do you think this waterfall model has? And give an example of a project that might succeed with this waterfall model. So I'm going to give you 1 minute. Quickly talk about this. What's wrong with this process? What's wrong with this process? But where could it work? Where could it work? Please go ahead. Please talk. Actually, you know what? Let's pause for a second. Sorry to interrupt. If you have a teammate who wasn't here on Tuesday, I'm going to add a little bit of time to this. Tell your teammate, introduce yourselves. Hello, yes, my name is. Please tell your teammate what we were doing, and then we'll come back to this. So I'm actually going to give you about 2 minutes, 2.5 minutes to get to this, okay? Please go ahead.
One person replied to our email, but
Okay.
he said he'll start coming next week.
Okay.
The other two.
Okay. So stick together for now.
Yeah.
If one person's definitely coming next week, then I don't know if I'm going to change anything about this.
Okay.
You're going to get to tell them what project they're working on, though, because you're going to be making the decisions.
Yeah.
You can change, of course, but in that you're going to be starting to work on it today, you might as well just keep going with that idea, right?
Yeah.
The other two people, if they're still ghosting you, send me an email, please, okay? If you don't get in touch with them by like Monday next week, then let me know what's going on, okay? Okay. Hey.
One of our members is like working this term. He said
Okay.
that he has a work term, so he's not going to be attending.
That's kind of his problem. I mean, you are here now, and you are going to get project work done while we're in class. And that's kind of got to be something that when it comes to peer evaluation time, that you're assessing how much and how often somebody is contributing. If this person is able to make up the time, like they're not coming to class, but they're able to make up that time and effort outside of class.
No, he's like work term, like I guess a call.
Oh, then he should be kicked out of the class?
Yeah, he's going to be removed.
Okay. The class list may still be changing because the revision period doesn't end until next week, I think, sometime. So you may get somebody assigned to your team. If this person gets kicked out of the course because they're doing a co-op work term, then you might get somebody new, and you'll just have to kind of bring that person up to speed when they get assigned to your team, okay? Is that okay? Okay. All right. So what I want you to do with this now is I'm just going to tell you my take on this, and I want you to kind of mentally confirm or reject whatever you came up with independently about this. But I want you to use this idea, the stuff that you've come up with now, we're going to use this as a kind of a compare and contrast with an agile process. So the waterfall model is a model that works okay when there are problems that are discovered early in this process. So here's our waterfall model. We've got our requirements gathering team here working on requirements gathering, and then passing off to our architecture team, and then passing off to our dev team. You're the dev team, right? Yeah, you're the dev team. And then passing off to our testers. If the requirements gathering team figures out immediately, this is an NP hard problem. We just have to stop. This is not possible for us to build this software. The project is over. We're done. Finished. That's not a success, I guess, but the project is over. The problem was discovered very early. There's no issues with it. The requirements team does their job. They produce the requirements document, and they pass it off to the architecture team. The architecture team starts architecting, and they realize there's something missing in the requirements. There's this part that's like a question mark, question mark, question mark. I don't really know what to do here. The architecture team now has to pass it back to the requirements gathering team so that the requirements gathering team can go back to the client and say, hey, our architecture team figured that there's something missing here and we don't really know what to do. What do we do? But they're already working on something else. Now they have to spend time like outside of that work that they're doing right now to figure out how to fix that with the client. And that's okay because they haven't gotten too far away. The client hasn't just like skedaddled and started working on their own thing, waiting for the product to come out at the end. The requirements team figures out the problem. They pass it back to the architecture team. Everything's great. They pass it to the dev team. The dev team starts build. Oh, no. There's something wrong. OK, and now we have to keep passing it back and back and back. If we get to the requirements phase or the design phase and we say, hey, there's something wrong, it's not that costly to go back up one level. If we get to the phase of, I'm going to pass this off to my client now, and the client says, hey, you missed this thing, or, oh, it actually doesn't work the way that I thought it was going to work, you got to go all the way back to the top. If we find issues with this early, it's actually OK. It's actually OK if we find things early, and it's not so great if we don't find things early. This works OK in an environment that's stable. Your client really knows really well what they want. Your requirements team has worked with clients like this before. They know what to expect. The architecture team has designed applications like this before. Your dev team has built things like this before. The testers have tested things like this before. The delivery and maintenance teams have done this sort of thing before. When it's stable, it's OK if things are not going to change a lot as we go through the process. But It's rigid. This is the process. That's the process. Do not deviate from this process. My dev team does not gather requirements at all. They do not gather requirements. The requirements gathering team gathers requirements. My testing team tests. That is all they do. They enter data into the application and hope it works. The dev team has not been testing. They don't want to test. Going through this model is kind of a rigid approach. We can't detect tech problems early. My requirements gathering team, they don't know anything about Node. They don't know anything about the library ecosystem for JavaScript applications. My architecture team probably does, but they're not actually starting to build it. My dev team is actually building it. They actually see the tech problems, but we don't really get to see those tech problems until we get to the point of sitting down and writing code. This can be difficult to plan and schedule in the sense that it's actually super easy to plan and schedule because the requirements team is just going to take 2 weeks with the client, exactly, because they know exactly how much to do. The architecture team is going to take 2 weeks to come up with this architecture because they know exactly what to do. The reality, though, is we can't do things like detect tech problems early. We can't do things like figure out that there's a problem in testing before we get to testing. Planning out what each of these teams is supposed to be doing can be difficult to plan and schedule because if we have to go back, we have to adjust and change the schedule that we've already put together. We can also get to the end and our client can say to us, hey, you know, this is awesome, except it would be really great if it also did this other thing that I didn't tell the requirements gathering team. Then you kind of have to go back and do the whole thing all over again, and you have to replan and reschedule everything. If we apply this waterfall process rigidly as stated, our client doesn't see anything until we give it to them and pass it off to the maintenance team. They throw requirements into our requirements gathering team, and then they get something out at the end. And the rest of it, they might be involved, but in practice, most of the time, they're not really there very much. Agile is this idea that came about in like, I want to say 1990 something, 1999. You're all third year. Was anybody born before the year 2000? Just a few of you, and me, I guess, yeah, and me. So this came out before most of you were born. This idea came out before most of you were born. This idea came out in 1970. It was documented in 1970. It has been around for a long time. This idea came out in the mid-90s, mid to late 90s, and it was a response. This was a group of people that got together and said, hey, this waterfall approach, it's terrible. It's really bad. We've been doing this for a long time, and we realize that there's a lot of issues with the way that waterfall works, and we really want to get together as a group and kind of coalesce around something that makes it better for everybody, us as devs and project managers and clients all at the same time. You've read this Agile manifesto, this 4 points. I hope you've taken the time to take a look at this before class. But I'm going to take a stab in the dark and say that these words are mostly meaningless to you right now. That's totally okay. That is totally okay. Individuals and interactions over processes and tools. The waterfall approach to doing software development involved very detailed processes about how software should be designed. It involved very specific tools about how you should do Documentation, for example. The authors of the Agile Manifesto said, we think that the people who are important and the things that are important in software development are people, me, you all, the client. And we think that the interactions, and this is where that communication word comes in, the way that we're working with each other is more important than rigidly adhering to a very specific process. If something is going to change about what we're trying to get from our client, it's okay. I don't have to rigidly stick to this process. I want to work with this person to figure out what it is that I need to change. Working software over comprehensive documentation. The very first phase in Waterfall, please all shout it out on the count of 3. The first phase of Waterfall is 1, 2, 3. Oh, that was underwhelming. Okay, after 3. So the beat after 3 is when you should say it. 1, 2, 3. Thank you. Requirements gathering. And the requirements gathering team, you're going to be my requirements gathering team forever now. The requirements gathering team came up with comprehensive documentation, like literally 3 ring binders. There was a co-op job that I worked when I was in this class at IBM. I worked at IBM for a co-op term, and we were building a web application for farmers. I was working at Agri-Food and Agriculture and Agri-Food Canada, which they still hire people to work on the projects that I was working on as a co-op student. You're nodding your head. Are you working there? Did you work there?
No, I didn't, but I interviewed there and I thought I was going to end up working there.
Okay. My first day on the job was, here is a giant 3-ring binder of everything that this is supposed to do, including mocked up screenshots of what I'm supposed to build. It was like 1,000 pages long. Waterfall has our requirements gathering team going through this process of just building this whole thing without ever writing a line of code, without ever giving something that works to our client. The authors of the manifesto said, we should give something that works to our client as soon as possible. We should give them something that works, and we should be constantly giving them something that works, rather than telling them, hey, look, this is what it's going to look like when it's done. Customer collaboration over contract negotiation. Contracts are not something that ever went away. This is something that's still part of software dev. As devs, you won't see contracts very often, but the spirit of this is our customers shouldn't be giving us an exact amount of money for an exact feature set and then like hands off and then walk away. We should be working with our customer throughout the project. We should be giving them working software, and we should be making sure that the way that we're interacting with them allows them to collaborate with us. We want this person to be invested in the product that we're building, as opposed to just them writing down a giant legal document and giving us money and then hoping for the best at the end. I really personally think this is the most important point of that 4 points of the Agile Manifesto, responding to change over following a plan. I think the last point and the first point here are related to each other. Responding to change over following a plan is 2 things. One is the requirements gathering team gets some requirements, and then we build something, and then they get more requirements based on what we've learned and built from that. And then they get more requirements, and we build more based on what we've learned from that. We're not going to get this giant set of requirements up front and then plan out our work for 3 years. We're going to build something small and build on that, and build something small and build on that, and build something small and build on that. That's one part. That's the software dev part. The other part of this is, as we're going through the process of building software, as a team, we will adopt a method. We will adopt a process. There's going to be a way that we go about developing software. So maybe as a team, you will decide we want to do code reviews as part of this project. We want people to show the rest of their team what they've done before it gets actually put into the product at the end. And then you start doing it with your team, and then eventually, after trying it for a while, you realize this sucks. It doesn't suck, by the way. This is something you should do. But maybe you do collectively decide this is painful and not worth it. Responding to change over following a plan here is changing our process. Code review feels terrible for us, and it's not giving us any benefit. Let's just stop doing code review. Alternatively, and more realistically, we are constantly putting bugs in this software. We should adopt code review. Let's change the way that we're going about building this software. Agile, as stated in the Agile Manifesto, is not a methodology. It is not a process. The waterfall process is literally a process. These are the steps that you follow. This is not a process. There are no steps here. There's nothing that says these are the steps that you follow to accomplish this. These are just things that the people who wrote this very firmly believe about what software development should look like. Building software is something that involves exploration. Exploration is going to be, we're going to build something, we're going to try it, we're going to see what it's like, we're going to learn about it, and then based on what we've learned, we're going to make changes. As we're going through and observing, exploring the way that we're building software, we're increasing what we're doing, we're increasing experience doing stuff, and we're going to be increasing observations that we're making about this. Software, yeah, it grows organically, and it doesn't always have to turn into Frankenstein. It can be a good thing. Here are some examples of agile methods that you may have seen described before. If you are in co-op, maybe you've seen them used before. Extreme programming is quite old. This is the method that was described when I was a student that's not really that popular to use anymore. Scrum, if you've heard of Scrum, put your hand up. Some of you have heard of Scrum. Scrum is this idea that we've got this weekly or a certain amount of time that we're putting in between deliverables. There is a certain person that's called a Scrum Master. They're responsible for making sure that the team is following this process. It involves lots of things like daily stand-ups. There's this idea of Kanban, and Kanban kind of focuses on putting issues and tasks into a board specifically. There's lean software development, and this is trying to take as much of the process out, but to get something down to as minimal as possible. Our agile methodology it's not named. There's no name for what it is that I'm expecting you to do in this course in terms of following an agile method, but I believe that what I'm describing to you as a process does fit into what those authors of the Agile Manifesto said. Our approach is that I want you to build just enough upfront documentation before you get started with working on the project. I'm not going to be looking for you to build comprehensive documentation for this project. You're going to have just enough to get started before you get started. And as the term goes on, you're going to be expanding on the documentation that you're writing for this. You're going to be doing this iteratively. You're going to be doing repeated deliverables. So you're going to be building something and giving it to me, and then building something and giving it to me, and building something and giving it to me. And you're going to be doing this in an overlapped execution. So what I mean by overlapped execution is that you are going to be doing testing and implementation at the same time. These aren't two separate phases. They should be something that you're doing together as you're building the software. The iterations are time limited, and it's not just because this is like a university course where you have to have due dates with assignments and stuff like that, but They're time limited because we want you to deliver something. We want you to take what you've put together and actually give it to someone as it works in the state that it's in right now. It won't be finished. It will not be finished, and that is totally okay. You're going to be giving us a partially complete something, but it will work and it will do what it says it's supposed to do based on what you said you were going to do. And you're going to be working with your customer constantly. You're going to be working with your customer constantly because you're the customer. You're going to be the customer. You are going to be the customer. You're going to be the customer. So you are all going to know kind of what exactly this product and project is supposed to be resulting in the end. I also want you to spend some time, and I'll encourage you to do this, I'll give you time in class to do this, to look back at what's happened throughout the execution of one iteration and make changes to how you're doing things. So reflecting and then giving you the opportunity to make changes about what it is that you're doing. With that, what I'd like you to do now with your team is come up with what you think the most important difference is between waterfall and agile. At least the agile that we've described. Those manifesto points are not a process, but what I've described to you as our method is a process or a method. What do you find is the biggest difference between those two things, the most important difference? I'm going to give you about 5 minutes to talk about this, and then we're going to get back together and I'm going to ask you for some feedback. Please go ahead. Hey, is this your team?
No, basically I am on the waiting list.
Oh, okay,
so
okay. It's
just coming to the class and just.
If there's space for you to sit, I got no problem with that. Yeah. If you want to just glom onto a team, that's also fine. If you want to talk to people and work with them, that would be totally great. There's one team up there that has just 2 people.
I see.
And that might be a good way for you to start participating if you want to. Sure. But that's up to you. I'm not going to make you do that, of course.
I'm pretty sure I'm probably going to get into the class because I'm on like 5 right now.
Okay.
So
Okay. If you want to talk to people, that team just has 2 people up there.
Sure.
You might want to sit with them and just start talking. Introduce yourself. So what does your team think? What's the biggest difference? What's the biggest difference, do you think? Or the most important? Communication?
Yeah, between teams and customers.
Okay, yeah. So when we're looking at waterfall, it's very much just like bundle up and pass off.
Like if requirement team is done with that stuff, they're done.
Yeah.
They don't remember.
Yeah. But now everybody's kind of working together all the time. So they have to talk to each other. Yeah. Okay, good. I like that. Great. Hey.
What were the examples of for waterfall model?
What do you mean? What were the phases?
Examples, like you asked examples, right?
So I'm not sure what you mean. Like, what were the examples?
What could be an example for a waterfall model?
Like, what are the problems with waterfall, or
An example.
of it actually being used in practice? Oh, I mean, my co-op work term would be a good example of it, where it was just all the design was done up front. It was given to me in a binder, basically, and the rest of the team in a binder.
You know, like I'm asking, like, do we have to think in terms of apps or software? Like this particular software might be designed in this particular way.
That might be one thing that you can think of. So that's the second part of that first question that I was asking. And the example that I would give you is something where it's just like you know exactly what it is that you're building.
I was thinking, like, let's say we are designing a very simple thing that's only gonna do. Let's say one single thing.
Yeah.
Let's say opening a door.
Sure.
So we are just going to program that, and then we are done.
If you know exactly what it is, if you have a very firm idea, you've got a solid idea of what you're building, you know exactly how to build it, you know exactly what each of you are going to do, then waterfall will work perfectly. If you don't know what the door looks like, you don't know how heavy it is, or what shape it is, or how many people need to go through it at the same time, then maybe Agile is a better approach. Does that answer your question? Okay, good. All right. So, what I would like to get from you, I'm going to ask for some feedback. What I'd like to get from you is I'd like to get a sense of what your team came up with as the biggest, the most important difference between Agile and Waterfall. I'm going to ask teams based on random numbers. I love random numbers. I'm going to ask teams based on random numbers, based on team number. So the first team that I'm going to ask for feedback from is team number 3. What was the most important difference that you came up with between Waterfall and the Agile process that we've described? Oh no, now somebody has to talk.
Scary part.
Yeah. You spoke, now it's up to you.
Okay, so basically what we said is that waterfall, it's like a contract in a sense.
Okay.
The customer will give you a set of things they want.
Yeah.
And they'll only figure out how it works at the very end.
Okay.
Agile, however, you have something, the customer tells you, hey, I want this and that. But they'll know pretty much how it's going to be pretty soon, because Agile will give them the working result of at least a part of it. And they don't need to go through and follow through to the end of the project until the customer knows.
Okay.
Agile also doesn't really follow a set path. While Waterfall, it's like, step 1, step 2, step 3. Agile, it's like, yeah, we can go wherever, I guess.
All right. So Agile, we have a good sense of what it's going to look like throughout. And you don't have to rapidly write all this down. I'll give you a PDF of this page just so you know. We have a sense of what it looks like throughout. Okay, I like this. This is true for both the client and for us, right? Like, if you go through the process of a design team, an architecture team, building out what this thing is going to look like at the end, they are really the only ones that know what it looks like at the end. When they pass it off to the dev team, they'll start figuring it out eventually as they go through this process of reading the documentation that's been produced for them. but they don't necessarily know what it looks like. When you've got a client involved with you kind of all the time, you build little things for them to work with, figure out if this does work or doesn't work, and you give it to them, and they tell you whether it does or doesn't work. You're kind of working together to get a sense of what this is going to look like at the end. So that's great. Thank you, Team 3. The next team I want to pick on, I'm going to pick on 2 more teams here. So Team 1, our requirements gathering team. What did your team say was the most important or the biggest difference between the 2 approaches?
We agree with Team 3.
Okay.
Different.
Okay.
Like in our agile method, customer is us.
Uh-huh.
We do the customer, then we develop the project.
Okay.
So like the customer involved the project the whole time.
Okay. In our agile method, the customer is us. And that kind of implies that the customer is part of this the whole time. My writing is terrible. Is it readable at least? Okay. The customer is part of it the whole time. So I like what you said. You are the customers, and therefore the customer is part of it the whole time. One thing that, and this isn't in the notes, I know, but one thing that I've seen kind of espoused, this idea that's a good idea, is that your customer should be treated as though they are part of your team. So the reality, like in practice, you go out into the real world, you go into a workplace, your customer isn't the dev team. Not usually. Yeah, there are teams that build products for devs, like the team that's building VS Code or Visual Studio or Eclipse or IntelliJ or whatever. There are teams of people who are building software for other devs. But most of the time you're building it for somebody else. Treating that person or treating that group of people as though they are part of your team when you're building this is one way to accomplish this. We're doing this implicitly because we've got the dev team being the customer, but in practice, this is something that we can do. Thank you, Team 1. My next team to pick on is Team 9. That's you.
Very similar theme. It was mostly just like an increased communication with the customer.
Okay. I'm going to write this in really big letters. Communication, yes. So communication, you're specifically saying with the customer.
Yeah, I mean, you can see that going for everybody.
Yeah, so with the customer and really with everybody. One of the things that we saw with Waterfall was requirements team just throws something at the architecture team, and then they don't need to talk very much anymore. They can, like, it's not like you've got a project manager like putting a barrier between these groups of people, but they don't need to talk to each other very much. The testing team is definitely not going to be spending a lot of time talking to the architecture team. They don't care what the architecture team is doing. Communication is going to increase with something like Agile because you've got the client as part of your team. It's going to increase with something like Agile because you're doing testing as part of your dev team. It's going to increase with something like Agile because you're trying to build something small and work with the customer to make changes to what it is that you're building. You have to talk to your client to be able to figure out what it is that they wanted to do. Okay. Thank you, Team 9. That's great. Is there anything that any other teams want to add to this that they think is a glaring omission from what we've got between these important differences? Yeah.
Flexibility.
Flexibility, okay. I like that too, yeah. You're a lot more flexible with an Agile approach than you are with a waterfall approach, just by the very nature of what you're doing. With waterfall, yeah, that rigid following of the process, requirements, architecture, building, testing, maintenance. You just go through that every single time directly without spending any time being flexible about it. With agile, you're kind of making changes to what you're doing as you're doing it. I kind of like to think about agile in this sense as more of like a graph of nodes, and you're finding the path through this graph of nodes as opposed to this linear sequence of things that you're doing. That's great. Thank you, team. I don't know what team you are. 12, team 12. Thank you. Anything else? Yeah. So the tech problems can be discovered earlier? Okay. I like that. One thing that we can do with this is that we don't get this comprehensive documentation. We can talk to the client and just ask them, what's the hardest part of this, do you think? What is the hardest part of this? Another thing that I like about this tech problems discovered earlier is if tech problems are discovered later in Agile, you've got the whole team. You're all there. If you figure out later this is an NP hard problem, oh well, I guess. If you figure out later this is really hard, it's not that big of a deal. It's not as big of a deal as it could be because you don't have to go back to different teams. You don't have to ask other people to help you fix what maybe they omitted in the first place. You can just go to your client and say, hey, this isn't going to work the way that we thought it was going to work. Let's change it. What can we do differently? OK, this is great. Thank you all for sharing this. With that, I'd like to move on to taking a little bit of a look at the project that we're going to be building this term so that we can start to create some non-technical planning artifacts. The project that you're going to be putting together as teams this term is an Android application. The Android application that I'm looking for you to build is going to be entirely on the device. It's really appealing. It's really, really appealing to do things like use external web services and stuff. I really get that, but I want to constrain what you're building to be entirely on the device. Part of it is because it makes it a little bit easier for us to do testing when we get to that point of doing testing your apps, but also because I don't want you to come up with a bigger project that you can actually do in the time that you have for this course. If you want to do something that's a little bit bigger in scope and you actually start to work with external services, I would suggest that you take the second software engineering course, Comp 4350, to get a sense of what that looks like. For us, we're entirely limited to the device that we're on. We're going to have iterative delivery throughout the term. You're going to be giving me stuff throughout the term. As the term is going on, we're going to be changing what it is that we're asking you to do. The first iteration, and we're computer science people, so we start counting at 0. It wasn't just a counting mistake on my part. The first iteration that we've got is just entirely non-technical planning and non-technical planning artifacts. There's no code for iteration 0. You won't be building any code. You won't need to open Android Studio yet before you start doing anything. We're just putting together plans, what it is that we're trying to build. The goal for us, for you, and for me is for me to be able to look at your plans and say, yeah, that's OK, or no, that's going to be way too big, or no, that's going to be way too small. The first iteration, iteration 1, is going to be where you start building some minimal feature set of the app that you're proposing to me and start to do some unit testing, some basic unit testing, so using JUnit and building some code. In the second iteration, you're going to be building more features of what you've described, and then you're going to be hooking in a relational database, so starting to use relational databases for persistence as opposed to just using in-memory objects. And the last iteration is going to be more functionality, so it's going to be closer to what it is that you originally planned, and then some acceptance testing. The acceptance testing that we're going to be asking you to do is to have software that's like literally clicking on buttons in your app. So actually going and testing from a button click all the way down to a relational database and then back to the UI. That seems like a lot right away, but this is a 3-month-long project. You will have lots of time to work on all of these things. Are there any questions about the project before I get into the non-technical planning artifacts? Good, good. OK, excellent. All right, planning artifacts. When I use this word artifact, just to clear up the terminology that I'm using, when I use the word artifact, I am talking about just stuff, things that you're putting together that are related to planning. Documents is not necessarily the right word for me to use. I don't always expect you to be putting stuff down on a sheet of paper and then printing it out and putting it somewhere. The things that you're going to be putting together are not necessarily going to be on an 8.5 by 11 sheet of paper. It might be a bigger sheet of paper. It might be an entirely electronic form. So for me to say documents is not really true. Artifacts is just a word that I'm using to describe anything that you could be building that's part of planning. We need just enough to get started on this project. And there are 3 main types of non-technical planning artifacts that I'm going to be asking you to build for this. The first is an initial vision for the software. At a really high level, this is something that says what your project is going to be at the end. At a very, very high level, what your project is, who it's for, and what it's going to be at the end. The next one is a set of features or epics that are required to accomplish the vision. So I've got this great big idea. I need to break this idea down into smaller parts that are going to be necessary for my user to accomplish the goal that I've set out in the vision itself. The features or epics that you're building they're too big to actually do. They're too big for you to sit down and code. So the next part is to take that epic and break it down into smaller, more actionable user stories. This kind of person wants to be able to do this very specific thing for this reason. We're basically starting major problem, break it down smaller pieces, break it down smaller pieces, iteratively. Let's do a little quiz. This is a team-based quiz. Please feel free to talk to your team. Please take 30 seconds right now to nominate one person on your team to be the device holder. You got 30 seconds. Yeah, just one person.
They don't mind this.
Okay, I'm gonna click the start button. So please talk. This is a team-based exercise. All right, great, excellent. Typically, it's end users or other stakeholders. This term, you are the end users or other stakeholders, so you will be writing the user stories technically, but in practice, this is something that end users or other stakeholders do. It's not exciting until we get closer to the last one. The problem with Kahoot is that some people will try to gamble and strategize and just pick something so they get to the top. Yeah, yeah. Oh, okay, all right, all right. So, typically, user stories will have a small thing on them that is an estimate of the relative effort. So time is usually the relative effort that we're using here, but it could be other things like points and the priority. So how important is this thing? Objective and measurable success criteria. This is something that we will have in non-technical planning artifacts. And it can be part of a user story, but typically it's something that's at a higher level than user stories. Whoa. This one is not for points. This one is just pick which one you think is the best. It's not for points. It's not for points. You don't have to race. All right, okay. So yes, I really, really agree with you here. I like this one the most. We know who it is that wants to do this. We know what it is that they want to be able to do. We want to be able to see grades, and we know why they want to do it, so they know if they passed. This one is bad. The blue one is bad, or it's not appropriate, partly because we don't know who wants to do this. But another thing is that it includes a technical term. List is a word that we have all internalized. We CS students and engineering students all know that this word list means a specific thing, is a data structure, and there's an order in that data structure. It might be like a numeric list on a sheet of paper. That might be it. But as a dev, you're already starting to think about what that thing looks like and how you're going to implement it. We're not at that point yet. Our users are not at that point yet. They just want to be able to see or do something. This one is better. It's for somebody, but now it's starting to tell me how it's going to be accomplished. I'm going to click this button. That's not a good user story because it's telling us too much about what's going on or how it's going to be accomplished. This one is better. We know who it's for, but it includes technical terms, and it really doesn't give us a reason for why this person wants to do this. Why do I want to be able to see a list of my students? Why do I want to be able to see which students are registered in my class? That's a better way to say that. I don't want to see a list of students. I want to see the students that are registered in my class so I can email them. That's what I want to be able to do. OK, here's the last one. This one is actually for points.
But I feel like the circle is more.
OK, great, excellent, great, 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 great. An epic is just this big thing that we want to ultimately to be able to break down into smaller user stories. They look similar. They really do look similar. They have very similar features and attributes, but one of them is just at a bigger scope than the other one, and we're breaking that scope down into smaller pieces for the user story. OK, drum roll, please. That was a terrible drum roll. Team 2, hey! For the record, I really love the name Runtime Terror. I really love that name. That's great. OK. We are rapidly approaching the end of class time, and I want to be respectful of your time. So I'm going to start telling you about this document, but we will start planning it next week in class. We will work. This is the very first thing that we're going to work on. With that in mind, your jobs as teams by Tuesday is to have a solid idea of what the project is that you're doing. So we will put this vision together. We will put this vision statement together on Tuesday next week, but you have to have an idea of what you're building before you get to that point. So over the weekend, your job now is to get in touch with each other if you haven't already and figure out what the project is. So let me tell you about this quickly, and then we'll end class. So a vision statement is the highest level planning artifact that you're building. And the purpose of this is to describe the project that you're going to be building. Really importantly, this is an artifact that defines what the project is. It does not in any way describe how it will be implemented. It does not in any way describe how you will be implementing this thing. A vision statement usually starts with one single sentence. This is what we're going to put together in class next week. Ultimately, there's 1 to 3 pages that describe what your product is going to be, but a single page is best. Having something that is concise, that describes what it is that you're trying to build is best. The vision statement itself does 3 things. It tells the reader what the project is going to accomplish. It tells the reader why the project is valuable and who the project is valuable to. This is partly identifying your users, your end users. Who are they going to be and why are they going to want to use this product? How is it going to make whatever it is that they're doing better? And what are the success criteria that you're going to use at the end to decide whether or not you have met that goal of making this thing better for the person that you're trying to build this for? Unstated benefits of this exercise of going through and figuring out what the project is going to accomplish, why it's valuable to who, and the success criteria are that as a team, as a group of people, you will all at the beginning, before you start doing this, have your own independent idea of what it is. You're all going to come up with this idea and you're all going to think of it slightly differently. One outcome from going through this exercise is that you're all going to start to have a better collective idea of what it is that you're building, as opposed to 4 or 5 separate ideas of what it is that you are building. So we will start doing this on Tuesday, and I will otherwise, I think I'm going to cut it here. So I'm going to quickly switch over to my comic, and I hope that you all have a great weekend. Bye, everybody.